Hello everyone, welcome once again to my channel. Now we have the last set. This is another question on method of movement. So the question says that let x1 all the way to xn be a random sample for the distribution with PDF that to f of s given the piecewise function 2 beta minus 2x divided by beta squared, and then we are given the condition that 0 is less than s, which is also less than beta. And the question says that we should find a method of moment estimator for beta. So in this case, realize that in this case also it is a continuous case. So in a continuous case, we are given the u of s, which is equal to the s bar, which is the mean, equal to the square root of x, f of x here dx, given positive, negative here. So in this case, we have s bar here being equal to so we are given these conditions over here, that is from 0 and then beta here. So from here we are just going to have the upper limit to be beta and then the lower limit to be 0, x here multiplied by the piecewise function, so x multiplied by 2 beta minus 2x here divided by beta squared in this case. So we have the x here. So from here we have our x, the mean here equal to, so whatever is not related to x here, we just substitute that one out, which is just so basically what we can do is to just substitute 2 outside here, so just bring 2 outside here and then divided by the beta squared here, and then we have beta 0. And now what we are left with is x here multiplied by, because 2 is here, that's why we substitute it out. So we are left with beta minus x here and then the x here. So in this case we have this to be 2 beta squared, and then the integral beta here 0 here, and then we have beta x here minus s squared dx, right? So from here straightly we go and then integrate from here. So we have the mean here being equal to 2 over beta squared, and then integrating this we have b s squared, because we add plus 1 to the exponent, then we divide by 2, and over here we have s, we add plus 1 to the exponent, s cubed, then we divide by the exponent, which is cube here, and then we have beta here and then 0. Good. So from here we just have the mean here to be equal to 2 over beta squared, and then we just substitute beta into the whole thing. So we have beta, and then remember we have beta squared over 2 minus just beta cube over 3 here, all of this minus just substituting 0 into it. So if you substitute 0 into, you realize that everything here goes, just substitute 0 goes to 0, and then we have s bar being equal to 2 over beta squared, and then over here we have beta multiplied by beta squared, which is beta cube over 2 here minus beta cube over 3 here. So we have this one here. So from here we have s bar being equal to 2 over beta, this beta, and then just find the LCM, which is 6. This goes into that, we have 3 beta cube minus this goes to that 2 beta cube also. So from here I just have the mean here to be 2 over beta squared multiplied by this, is just going to give us beta cube over 6 here. 2 goes into 7, 1 goes here 3, and then we just have the mean here being equal to this this side also 2 goes away and then it cancels that, so we are just left with beta over 3 here. So beta over 3 here, and then from here we can then know what beta is. From here beta is basically equal to 3 multiplied by the mean, and that is what, so that will be the estimator for beta in this case. So thank you very much for joining me in this section. Now in our next section, we are just going to look at we have two variables, like we have two variables and then we have to solve them simultaneously in the case of method of movement. So we are going to look at that, two different examples on that, then we'll just move to maximum likelihood. So thank you very much for joining me in this section. I will see you in the next section, which will be on method of movement. But then in this case, we have two different variables that we have to estimate them and then get their the system of equation and then get the value for each one of the variables. So I'll see you in the next video.